Hi, kids. Hi, kids. All right, we're going to do a little problem here where we're going to determine the critical angle for water in air. So, I would recommend one thing that I always recommend, which is let's try to sketch a picture for this. So, if I have my surface, and on the top I'm going to say I have air, and below I have the water. N of air is 1. N of water is 1.33. Okay. If I sketch a normal line here, I'm not going to use a protractor. I'm just going to sketch everything. But if I want to know the index of refraction, or the critical angle for water in air, well then that means my light has to start in the water. Remember that critical angle only occurs if the light is speeding up. So if you're going, you have to go from the water to the air. So now it doesn't matter which side I start on. Let's say I'll start over here. Okay, I'm going to have my light coming up. Okay? Now the critical angle by definition is the angle at which the light bends right along the surface, so that if it bends right along the surface, that means my refracted angle is 90 degrees. Why 90, you ask? Well, let me tell you. 90 because you have to measure from the normal line. So remember, you're always measuring from the normal line, so it'd be 90 degrees there, and this would be your critical angle. So if I'm going to use Snell's law to solve for that, remember Snell's law is N1 sine theta 1 equals N2 sine theta 2. So that if I try to plug in my numbers, I'm going to use a darker color so you can see it a little bit better. My N1 is 1.33 sine theta critical, because that's what I'm looking for, that angle, equals 1 times the sine of 90. If you do the math, let me grab a calculator. Still here, kids, just grabbing a calculator. If you do the math, you get 1 sine 90 is 1. So I go 1 divided by 1.33, and you get 0.75. So if you hit, remember, the second button, second, and then sine. So I'm going to go second sine of my answer, and I get my critical angle to be 48.8 degrees. Love it! Bye, kids. Well, actually, you know what? Before I say goodbye, let's talk about what this actually means. Let's just remember a couple things. So, if the angle of incidence is less than the critical angle, so let's say I have a light coming up like this. Now, if it's less than the critical angle, that means it is going to refract. If the angle of incidence is greater than the critical angle, like so, then you are going to have total internal reflection. So it's going to reflect, where now my angle here and my angle there have to follow the law of reflection. So they will be equal. So total internal reflection, critical angle, and then just regular refraction. Awesome. Bye, kids.